Welcome back to Tech Stack. In this video, we'll cover everything about Angular 19 in detail. Like every Angular version, there are small but impactful changes. Core concepts remain the same, but each release introduces new features and improvements. AngularJS, Angular 1, was completely different, but from Angular 2 onwards, the framework has stayed mostly consistent. However, starting with Angular 17, some major changes were introduced, like the standalone components API. In this tutorial, our main focus will be on all the new updates from Angular 17 onwards. Who can learn Angular? If you know HTML, CSS, and JavaScript, or have some experience with them, you're ready to dive into Angular. Angular is a powerful front-end framework by Google, used to build dynamic and scalable web applications. It follows a component-based architecture, making development modular and efficient. With features like two-way data binding, dependency injection, and a rich ecosystem, Angular simplifies complex UI challenges. Stay tuned as we explore the latest in Angular 19. To work with any JavaScript framework, whether it's Angular, React, or Vue, you'll need to have Node.js installed on your system first. It provides the runtime environment and package management, npm/yarn, that these frameworks rely on. Installing Node.js is super simple. Just go to the official Node.js website, download the LTS version, and run the installer. It's just like installing any other software on your computer. After installing the software, open Command Prompt and type these commands. If Node.js installed successfully, you'll see the version number here. In my case, it's version 10.9.2, but your version might be different, and that's completely fine. Angular works with most recent Node.js versions. Next, install VS Code. Just visit Visual Studio Code website, download, and run the installer. That's it. Next, we need to install Angular CLI. Angular.dev is the official website for Angular. The latest version is Angular 19. First, let's understand Angular CLI, the command line interface for Angular. It's your main tool for creating everything in Angular: projects, components, services, all through simple commands. To install Angular CLI globally on your system, use this command. Since I already have it installed, I won't run this command. After running this command, we need to verify whether the CLI installed successfully or not. For this, we'll use the command ngv. Perfect. Our setup is now complete. We've installed all the essential tools: Node.js for runtime and npm, Visual Studio Code powerful code editor, Angular CLI command line tool for Angular. To create a brand new Angular project, we'll use the Angular CLI. The command is straightforward: ngnew followed by your desired project name. For example, you might type ngnew project name. All right, open your command prompt or terminal and navigate to the folder where you want to create your new Angular project. This is where ngnew will do its magic. Type ngnew Angular project and press enter. It will prompt you to choose a style sheet format. Select CSS. It will ask if you want to enable server-side rendering, SSR. Choose No and press enter. Now it's installing packages using npm. This may take a little time, so let's take a moment to explain what npm is. First, open the project in Visual Studio Code, then open the package.json file. In package.json, you'll see the list of packages installed via npm. These packages are downloaded and stored in the Node Modules folder. When we create a project, it automatically reads the package.json file, uses npm Node Package Manager to download the required packages, and saves them in the Node Modules folder. npmjs.com is the official website for npm, the Node Package Manager. It hosts a vast registry of open-source JavaScript packages and libraries. Developers use it to find, share, and manage code packages for their projects. In package.json, the version of Zone.js is set to 0.15.0. Let's search for Zone.js on npmjs.com. You'll find the same version on npmjs.com because npm installs the latest compatible version of each package based on the Angular version you're using. You can see that there are many packages inside the Node_Modules folder. This happens because, along with each package, its dependent packages are also installed automatically. Now, let's explain the difference between dependencies and dev dependencies. This is an important interview question. Dependencies are the packages your application requires to run in production. On the other hand, dev dependencies are only needed during development, like testing frameworks or build tools, and they aren't included in the final production build. Package.json is a file that lists your project's packages and their versions. It also contains important metadata and scripts to help manage your project. Next, let's look at Angular.json. This file contains the configuration settings for your Angular project, including build and development options. Next is the public folder, which replaces the assets folder from previous Angular versions. The public folder holds static files like images, fonts, and other assets that your Angular app needs to serve directly. Next is the src folder, which contains the main source code of your Angular app, including the important index.html file. Angular builds single-page applications, SPAs, which means the entire app runs within a single HTML page, usually index.html. Instead of loading new pages from the server, Angular dynamically updates the content, providing a smooth and fast user experience. The entry point for index is specified in the angular.json file. This tells Angular where to start loading the application's main HTML page. Main.ts is the entry point of your entire Angular application. It's the first file that gets executed when your app loads in the browser. This main.ts file is the starting point of the Angular application. It imports the Bootstrap application function from Angular's platform browser package to bootstrap the app. It then loads the root component, app component, along with its configuration from appconfig. Finally, it starts the application and catches any errors that might occur during bootstrapping. Next is appconfig.ts, which replaces the traditional appmodule.ts used in older Angular versions to configure and bootstrap the application. Appconfig defines the application's configuration by setting up providers like change detection and routing. It replaces the old app module approach with a simpler modular setup. Style.css is the global style sheet for your Angular application. Styles defined here apply across the entire app unless overridden by component-specific styles. AppRoutes.ts is used to define the routes for your Angular application. It exports a routes array, which will hold the mapping between URL paths and components. Now, let's talk about components. In Angular, a component is like a page or a section of your application. Each component controls a part of the user interface. Components are the building blocks of Angular apps, and multiple components work together to create a complete application. By default, Angular creates the app component, which is the primary or root component of the application. It acts as the main container, and all other components are typically loaded inside it. Each Angular component comes with three main files: an HTML file for layout, a CSS file for styling, and a TypeScript file, .ts, for logic. Additionally, there's also a .spec.ts file, which is used for unit testing the component. HTML file contains the structure or markup of the UI. CSS file holds the styling. TypeScript file contains the variables and functions that handle the logic and behavior of the component. It's called a decorator. In Angular, a decorator is a special function that adds metadata to a class, telling Angular how to use it. For example, the addComponent decorator tells Angular that the class is a component and defines its selector, template, and styles. Let's create a new component. First, let's create a new folder named Pages. This helps keep our components organized, especially when building a large application with multiple sections or views. Now, open the Pages folder in the integrated terminal. First, create a new component by running the command ngCusers. This will generate a new folder named Data Binding inside the Pages folder with all the required files for the component. Now, let's create the second component using a slightly different command, ngGenerateComponentDataBinding. This command does the same thing as ngGC, but it's the full form. Both commands are valid and commonly used. Both the data binding and users folders contain 4 files each: the TypeScript file for logic, the HTML file for structure, the CSS file for styling, and the spec file for testing. Each component has a unique selector defined in its decorator. This selector acts like a custom HTML tag that you can use to include the component anywhere in your application's templates. Now run the project using the command ngserve. This will compile your Angular application and start a local development server. The project is now being served on localhost 4200. Open this URL in your browser to see your Angular app in action. By default, the app component is the root component of an Angular application. That means all the data and views you see when the app loads initially come from the app component. Let's clear out all the default content from the app component template and replace it with a simple heading. Now press Ctrl+S to save the file. Angular's development server detects the change and reloads the app automatically. No need to run the command again. Now, let's render these two components inside the app component. Now, copy the selector of both components, for example, app data binding and app users, and use them as custom HTML tags in the app component.html file. An error occurred saying app users is not a known element. This happens because Angular doesn't recognize the component until it's properly imported. To fix this, we'll import both components in the imports array of the app component.ts file. Perfect. Both components have rendered successfully, and everything is working as expected. We can also render components using self-closing tags. From Angular 17 onward, all components are standalone by default, meaning standalone. True is automatically applied. However, we can still explicitly set it to true or false if needed. Before Angular 17, we had to manually specify standalone, true for each standalone component. Standalone components are Angular components that work independently. Next, let's talk about routing. In Angular, routing enables navigation between different views or pages within a single page application. It dynamically loads components based on the URL, providing a smooth user experience without reloading the entire page. So now, we'll add a simple navbar with links to users and data binding. When we click these links, the corresponding components will be displayed using Angular routing. Now go to the approutes.ts file and define the routes. We'll map each path to its respective component, so Angular knows which one to load. We've created routes for users. Path defines the URL, and the component tells Angular which component to load when that path is visited. Now, let's create a similar route for the data binding component. Now let's create a default route. When URL path is empty, we'll redirect the user to the user's page. For this, we use path empty, redirect to, users, and path match, full. This ensures that when the app loads with no specific route, it automatically redirects to the user's component. Now we've created 3 routes, one for users, one for data binding, and a default route that redirects to users when the URL path is empty. Now we'll add a navbar inside the app component. I've already created the navbar code. Now, let's copy and paste it into the app component. You can see the navbar has loaded successfully. Let's now remove any unnecessary links from the navbar. Now, let's replace the plain ref links with Angular's router link directive. This ensures smooth navigation without page reloads. Using router link makes the app faster and maintains the single-page application behavior. To use router link in our template, we need to import router link and add it to the imports array in app component.ts. You might notice routing still isn't working yet because we haven't added the router outlet in the app components template. This tag tells Angular where to display the routed components. Perfect. Routing is now working smoothly, and our components load correctly when navigating through the navbar links. In this video, we'll explore variables and data binding in Angular. We'll cover variables, interpolation, property binding, and event binding. Let's start with variables. In Angular, we define variables inside the TypeScript TS file of a component. These variables hold data, which we can then display or manipulate in the HTML template. Think of them as the link between your component's logic. Let's declare a variable called student name. Here, student name is a string type variable, and we've initialized it with an empty string. Let's declare another variable called current course. Here, we haven't explicitly defined the type. Angular automatically detects that it's a string based on the assigned value. This is called type inference, and it's a handy feature of TypeScript that makes your code cleaner while still being type safe. In JavaScript, we usually declare variables using keywords like var, let, or const. In TypeScript, we don't use var, let, or const inside a class to declare properties. Instead, we declare variables directly with optional type annotations. Now let's declare another variable named isActive. In TypeScript, we specify its type as Boolean. This means isActive can only hold true or false, which helps catch bugs and makes the code easier to understand. Now, let's discuss interpolation. Interpolation in Angular is used to display component data in the HTML template. We use double curly braces to bind a variable from the TypeScript file to the HTML. So now we will bind student name, current course, and isActive variables to the HTML using interpolation. We've declared 3 variables in our component: student name, current course, and isActive. Using double curly braces, we've displayed their values in the HTML using Angular interpolation. Whenever the values of these variables change in the component, the HTML will automatically update. Let's now discuss property binding in Angular. Property binding is used to bind values from the component, TypeScript, to DOM properties, HTML elements. This allows you to dynamically control element attributes like src, disabled, value, etc. Now we'll create an input element of type text in the HTML and bind its value attribute to the student name variable using property binding by wrapping the attribute in square brackets. Perfect. Our property binding is working correctly. Now we'll demonstrate class binding in Angular. First, let's declare two variables, marks to store a numeric value and marks class to dynamically assign a CSS class based on the marks. We'll bind the marks class variable to the class attribute using Angular's class binding syntax. The marks class will dynamically hold either pass or fail based on the value of marks. Next, we'll define CSS classes to style the background color based on the result. The .pass class will have a green background, and the .fail class will have a red background. Now, let's define the criteria inside the constructor to set the marks class dynamically. If marks is less than 50, we assign the class failed. Otherwise, it can be pass. Since marks is set to 84, the marks class is assigned pass, so the background color appears green. Now, if we set marks to 39, the marks class will be failed and the background will turn red to indicate failure. Next, we'll demonstrate dynamic input types by using a variable called input type to control the type attribute of an input element. First, we assign the value radio to the input type variable. Now, create a new input element in the HTML and bind the input type variable to its type attribute using property binding. Perfect. Now you can see the input rendered as a radio button. Now, change the value of input type to checkbox. Perfect. Now you can see the input rendered as checkbox. First, we try binding the isActive variable to the checkbox using the value attribute, but it won't reflect the checkbox state correctly. Instead, we should use property binding with the checked attribute to properly bind the isActive variable and control the checkbox state. As you can see, it works perfectly when using the checked attribute. In Angular, checkboxes should be bound to check to reflect their true state, while other input types like text should be bound to the value attribute. So far, we've learned how to pass data from the TypeScript.ts file to the HTML template using data binding techniques. Now, let's move on to event binding. Event binding in Angular allows us to capture user actions from the template, like clicks or key presses, and trigger methods defined in the TypeScript file. First, create a button labeled Show Alert and bind a click event to trigger a function when it's pressed. Now, create the Show Alert method in the TypeScript file to display an alert message saying, "Welcome to Angular course." Now, bind the Show Alert method to the button's click event using Angular's event binding syntax. Perfect. It's working flawlessly. Now, create another function named changeCurrentCourse that updates the value of current course. Typing this provides access to all properties and methods defined within the current class. Create two more buttons and bind their click event to the changeCurrentCourse method. Pass the respective course names as arguments to update the current course value dynamically. In Angular, you can place the debugger statement inside your code to pause execution and inspect variables, call stack, and application state using browser developer tools. Before clicking the button, open your browser's Inspect Developer Tools to enable debugging. This allows the debugger statement in your Angular code to pause execution when the button is clicked. You can see that the value of current course has been successfully updated. Angular's change detection automatically updates the view whenever the current course value changes in the component class. Now we will discuss two-way data binding in Angular, which allows seamless synchronization between the component class and the template. To demonstrate two-way data binding, we'll use the student name variable as our example. Create a new input field and bind the student name variable using ngModel for two-way data binding. An error occurred. Can't bind to ngModel since it isn't a known property of input. To resolve this error, we need to import FormsModule into the imports array of the component, as ngModel is part of Angular's FormsModule. This allows us to use two-way data binding properly. When we update the value in the ngModel bound text box, the above displayed values update automatically in real time due to two-way data binding. Next, we'll dive into signals, a powerful new way to manage reactive state in Angular. Signals in Angular are reactive primitives that hold a value and notify consumers when that value changes. They simplify change detection by making it more predictable and efficient, reducing the need to manually trigger updates. With signals, Angular can work with or without Zone.js, offering better performance and finer control over UI updates. Navigate to the Pages directory and open the integrated terminal. Now, let's create a new component named Signals. Now let's add a route for the signals component in the app routes.ts file. Now, update the navigation bar in app component.html to include a link to the signals component. Run ngserve in the terminal to start the Angular development server and verify that the signals component loads correctly without errors. Awesome. The signals component has loaded successfully and is working as expected. Now we'll define a signal-based variable named counter and initialize it with a value of 0. Import the signal function from Angular core. You can explicitly define the type of a signal like this. This makes it clear that counter1 is a signal holding a number, helping with type checking and better IDE support. It's especially useful when the initial value is null or undefined, or when you're working with complex data types. Now let's display the counter value in the HTML template. In the case of signal variables, you can't access the value by just using the variable name. You must call it like a function using parentheses. Now, let's create an increment function to update the signal variable. Signal values can be modified using the set or update methods. Next, add a button in the HTML to call the increment function when clicked. Bind the increment function to the button's click event using Angular event binding syntax. When you click the increment button, it increases the value of the signal variable. The increment button is working perfectly as expected. Let's first look at how a normal variable behaves inside Angular signal system. We declare a regular variable course normal. We declare a signal variable course signal. Create a change course function, and inside it, update the course normal variable by setting its value to Angular. Inside the constructor, use the effect function to log the value of the course_normal variable to the console. Create a button in the HTML and bind the change course function to its click event. Now here's the key point. When you click the button to change the course, it updates the value successfully, but console.log inside the effect does not run again. That's because normal variables are not reactive. Angular signals can't detect changes to regular variables automatically. So the effect only runs once when the component is initialized. Now inside the change course function, update the course signal variable to Angular using the set method. Now inside the constructor, use the effect function to log the value of the course signal variable to the console. When you click the button, not only is the value updated, the effect is automatically re-triggered and logs the new value. That's the power of signals. They are reactive and integrated into Angular's change detection system without relying on Zone.js. So in short, only signals are tracked reactively, which is why you see the console log update for signal variables, but not for normal ones. Next, we'll explore Angular's control flow statements at if, at else, at for, and at switch, which allow us to handle conditional rendering and looping directly in the template using the new declarative syntax. Let's begin by creating a new component named control flow where we'll demonstrate Angular structural directives like at if, at else, at for, and at switch. Next, open app_routes.ts and define a new route for the control flow component so we can navigate to it via URL. Now open app component.html and add a navigation link for control flow in the navbar using router link. Now open the terminal and run ng serve to verify that our new component is working correctly in the browser. Perfect. Our component is working as expected. Now let's begin by implementing the add if template syntax to conditionally display elements based on a condition. First, declare a variable named isLoggedIn in your component. Then, in your HTML, use the add if template syntax to conditionally show content based on this variable. As you can see, it worked perfectly. Declare a variable called hasAccess and set it to true. Now, using the if, and else template syntax in HTML, you can conditionally display content. As you can see, it worked perfectly. We declare an array called courses containing 3 strings: Angular, React, and Java. To render this list in HTML, we use the for template syntax to loop over each course. As you can see, it worked perfectly. We declare a variable role with the value user. Using the @switch statement, we check the value of role and render the appropriate message. As you can see, it worked perfectly. So, in short, control flow statements like @if, @else, @for, and @switch enable dynamic, conditional rendering, and iteration in templates, making UI logic clear and efficient. In this video, we'll explore how to use NgClass and NgStyle in Angular to dynamically apply CSS classes and inline styles. Navigate to the Pages folder and open the integrated terminal. Create a new component named Dynamic Styles. Next, open App Route and add a route for the Dynamic Styles component. Now, open App Component HTML and add a navigation link for the Dynamic Styles component in the navbar. Now, open the terminal and run ngServe to verify that the Dynamic Styles component is working correctly. Perfect. The component is working correctly. Declare a variable marks and initialize it with 40. Bind a marks variable to an input field using ngModel. The error can't bind to ngModel since it isn't a known property of input occurs because the Forms module is not imported in component. Place a paragraph tag and display the marks variable inside that paragraph. Add an ngClass directive to the paragraph tag that applies the class green when marks is greater than 50. Otherwise, it applies the class red. To use ngClass, make sure to import ngClass in imports array. The green class will set the text color to green, while the .red class will set the text color to red. To fix this error, simply remove the curly braces from your code. You can see that ngClass is working perfectly, dynamically changing the color based on a marks value. Import ngStyle into the component's imports array to enable dynamic styling. Now add a paragraph tag and apply ngStyle to it. If the marks are greater than 50, set the text color to green. Otherwise, set it to red. As you can see, NgStyle is working perfectly. It's dynamically changing the text color based on the marks. If you found this video helpful, please give it a like and don't forget to subscribe and share.